In this video, we're going to be learning about the last formula that we use in sequences. So first we're going to look at this sequence here, and we're going to decide what type of sequence it is. So when I'm deciding what type of sequence it is, the first thing I do is I look here and I say, okay, how do I get from 2 to 6? Well, I'm going to write up here, I could be adding 4, or I could be timesing by 3. Well, how do you decide which one? You go to another pair of numbers. You could go to the 6 and 18. I'm going to go over here to these two because they're just convenient to put a circle around. Is 18 plus 4 54? I hope right now you're not putting that in your calculator. You can just tell yourself, no, it's not. So then we ask ourselves, is 18 times 3 54? That one is okay to type in your calculator, and you should get that, yes, it is. Okay, so we found out that our pattern here is going to be times 3. That means that that is our constant ratio. So if I write my recursive formula, I'm going to write f of 1 equals, well, my first term here is 2. The rest of the recursive function is f of x equals f of x minus 1. You guys should be really good at typing that in and writing it down now. And then you just put your pattern, times 3. So what kind of a sequence is this? Is it an arithmetic sequence or is it a geometric sequence? It is geometric because it is timesing to get from one number to the next. If it was adding, then it would be arithmetic. So the question now that we have to ask ourselves is, what is the explicit function? Well, we don't know how to do that yet. So what I want you to do is think about, or actually get some paper out right now, because at the end of the video, you're going to know how to do this, but it's going to be easier and you're going to learn more is if you actually try it with me. Don't just sit there and watch, because guess what? I'm going to do a good job every single time, but until you can do it, it's not going to help anybody. Okay, so our goal is to learn that explicit function today. What I want you to do right now is I want you to write down this explicit function. Make sure that you write down the descriptions under the blanks. I'm going to pause the video now. You should have had time to write that down. I hope while you were writing that down, you were looking at it and you're saying, what's different about this one from the arithmetic sequence? Well, the first thing that I noticed that's different is, hey, it's got a times instead of a plus in it. Doesn't that make sense, since the geometric patterns are timesing and not plusing? Okay, and then the next thing I noticed is that this is an exponent. Notice that it's little and it's written up. It is not just an x times a number. The last thing that I noticed that is different, and this is going to be something that you're going to have to remember every time, is that these are in opposite places than they were in the arithmetic. So when you're writing them down, you're going to have to get used to writing your zero number first and your constant ratio second. Okay, so let's just dive right in and do an example. Geometric sequence is given, it's 2, 6, 8. It's the same one that we were just looking at, but we've already figured out what our pattern is. Hey, we are timesing by 3 every time. So where does that go in the function? Well, that's our constant ratio, so it would go right here. But we have to figure out our zeroth term. Now, I've taught my students to draw a big circle there. The circle is telling us, hey, I'm looking for my zeroth term, but it's not part of the sequence. So that lets me know that it's just an additional number that I need, but it's not actually part of the numbers in the pattern. So the zeroth term, how do I get it? If I'm timesing by 3 going that way, going backwards, I'm going to divide by 3. Now, before you start typing this in your calculator and making it complex, remember that a fraction line is divide. 2 divided by 3. Now, you can type that in your calculator, and you're going to get 0.6666666. But we're just going to leave it. I don't want to have a fraction, a decimal, so we're just going to leave it as 2/3. So sometimes this can be easy to just write that fraction there. If it can divide out evenly, do it, but otherwise just leave it. So my zeroth term is 2/3. What we're going to do next is we're going to test this and check it. Okay, so how do I check it? Oops, sorry, I don't have that slide there. What I'm going to do is I'm just going to pick a term. Remember that my first term is 1, second term is 2, third term is 18, fourth term, and fifth term. It doesn't matter which one you pick. I'm going to pick 4. And I'm going to use my calculator, and I'm going to test it. The 4, when that's my term, that is my x value. So I'm going to take my explicit function here, and I am going to test it. So grab a calculator. Any calculator will do. I'm going to pull mine up now. I have to walk over my computer, so let me do this. And the function is 2/3 times 3 to the power of x. So I am going to make this go like this. Look, I'm so slow with this, but I know you're impressed anyway. Okay, so now I've got it squished over here. My calculators look like the ones that you use in the classroom. So, whoops, that went to the next slide. There we go. First, I'm going to type in 2/3. I like to use the fraction button. You don't have to, but I'm going to use alpha y equals. I'm going to choose number 1 there, and I'm going to type in 2/3. Now, just because you don't have this calculator does not mean that you cannot do this assignment. There are lots of other calculators that work. 2/3 is the same as 2 divided by 3. Okay, we're going to times by 3, and I'm going to do to the power. Notice how that bumps it up, and we were testing 4. Now, let's talk about what we should be getting. If we are getting 54 as our answer, because that is our 4th term, then we know that we're doing it right. Okay, so push enter, and I did get 54, so that means that I did do it right. Okay, I'm going to pull this over a little bit. Look at that. And I'll make it bigger in a minute, but we're going to use it on a couple just to kind of test our formulas, so I'm going to leave that out. Okay, let's look at this one. We want to first find our constant ratio, and then we're going to find our 0th number and recursive function and explicit. We're going to do it all. So looking at the thing right here, first thing I ask myself, it does say constant ratio, so that kind of gives me a clue. I'm looking for what it's timesing by. I don't need to ask myself what it could be adding. So how do I do that? These are bigger numbers. I'm not one that can do this easily in my head, so I would take and I would divide 45 by 15. Isn't it handy that I have my calculator right here that I can do that with? 45 divided by 15. Oops, I typed in 44. And I'm going to get 3. I know that's tiny to see, but hopefully you can see that. So my constant ratio is 3. Now I need to get my 0th number. Remember, if I'm timesing by 3 going this way, I'm going to divide by 3 going backwards. So what would I do? I would do 15 divided by 3. Now, you should notice that that one does come out to be a whole number. So if you need to type it in the calculator, hopefully you didn't, but it does give you 5. So instead of writing 15 over 3, why put a fraction when you don't need to? We're going to put 5. Okay, let's fill in our recursive function. We should be really good at this by now. My first term is 15. And then this is telling me my pattern is take the number before it, and I'm going to times by 3. Now, let's come over here and fill in the blank. My 0th number is 5, because that's right here, and then my constant ratio is 3. Once again, we're going to test this, and I know I have the slide on this next one. So let's plug it in. We're going to check f of 4 again. Remember, 1, 2, 3, 4. So if it's right, that means that I should, when I type this on my calculator, get 405. So I'm going to write here what I'm going to type in. 5 times 3 to the power of 4. Not times 4, but to the power of 4. So 5 times 3, let me make this a little bit bigger so you can actually see this, to the power of 4. Press enter, and I did get 405, so that means I did it right. Okay, so my formula is right. So here we go. Now we're going to figure out f of 8. 5 times 3 to the 8th. So 5 times 3 to the 8th. And when I type that in, I get 32,805. Okay, so far, hopefully you're doing well with this. What I want you to do is pause the video now and see if you can figure out the constant ratio, the 0th number, and go ahead and try to put it in the formula. I took the labels off, so you're going to have to remember what goes in each blank. Okay, hopefully you did that. Hopefully you actually tried it. Now that we're back, we're going to look here and say, okay, 4 divided by 1 hopefully you can do that in your head and figure out, hey, my constant ratio is 4. I am timesing by 4. So now we need our 0th number. If I go backwards, I'm going to take my first term and I'm going to divide it by 4. And when I look at that one, hopefully you notice that that does not divide out evenly. So I'm just going to leave my 0th term as 1/4. Okay, I'm going to go ahead and go straight to the explicit function. My 0th number is 1/4, and my constant ratio is 4. Now let's fill in recursive. F of 1 is equal to, my first term was 1, and then f of x equals f of x minus 1, and it is timesing by 4. Okay, let's go ahead and check this. Okay, it's always a good idea to check it because why get it wrong when you can just check it? And a lot of times what kids do is they will just have these backwards. Why not fix it? Okay, so let's go ahead and type this in our calculator. If I'm going to test f of 5, so this one's my 1, 2, 3, 4, 5th term, so I'm looking to get 256. What will I type in my calculator? 1/4 times 4 to the 5th power. Okay, so here I go. Once again, you can use 1/4. You can type it in as 0.25 if you knew that. You can do 1 divided by 4, but I'm just going to use my fraction method because I have one. Some calculators do, some are harder to figure out. 1/4 times 4 to the power of 5. Make sure you do to the power of, it's not just timesing by 5. And I did get 256, so that means that my formula is good. So now I'm going to type in 1/4 times 4 to the 9 to figure out the missing value. This time, you know what? Let's do 0.25. I just want to show you that if you know that 1/4 is 0.25, you can use 0.25 and it's still going to work out for you. Okay, and so when I type that in, I get 65,536. Okay, moving to the next one. Let's go ahead and pause the video so that you can see what you get, and then you are going to check it and make sure you got the right answer. Okay, hopefully you took that time to practice it. Now we're going to decide what each of our numbers are. So first step, I'm going to take -20 and I'm going to divide it by 5, and that tells me my constant ratio. Remember, the constant ratio goes in this blank. -20 divided by -5 is telling me that I'm timesing by a -4. So I'm going to plug -4 in there. To get my 0 term, I'm going to take 5 and I'm going to divide it by -4. You can type that in your calculator to see if it gives you a whole number. Hopefully you realize, oops, I put my marker down, but hopefully you realize without actually typing that in that you're not going to get one, but just for kicks and giggles, there we go. It gives you a decimal. I do not want a decimal in the formula, so we're going to leave it as -5/4. Okay, the important thing is, once again, we need to check it. It says to check f of 4, so let's look at our numbers here and decide which place in the sequence is that going to give us. So this is 1, 2, 3, 4. So in order for it to be right, that means that I should get -320. So here we go. -5/4 times -4 to the 4th power. Let's type it in. So I'm going to use my fraction again, or you could use the -1.25. It's your choice. So -5/4 times -4 to the power of 4. Oh boy, now this gave me 320. I'm supposed to get a -320, so that means something is wrong. So let's check and make sure that our negatives are where they need to be. Do you agree that 5 divided by -4 is going to be -5/4? I do. My next thing is do you agree that we are timesing by -4? I do. So we're going to have to think a little bit deeper. If we think back to last unit, in the last unit, anytime I gave you something to a power, if I gave you a negative in there, we have to think about this. A -4. If you think about that in your head, -4 times -4 is a positive 16. But if you type it in your calculator, I'm going to do that now, and use the square, -4 squared is going to give me a -16. I know the answer is a positive, but this tells me negative. So this has to do with the fact that we need to use parentheses when dealing with exponents. You will not get the problem right unless you put the parentheses. So please put those parentheses in there. Now let's type it in. Okay, we're going to go ahead and retype. So I got my fraction, -5/4. This time I'm going to put parentheses around my -4 and see if that works for me. Okay, plug it to the fourth, and it gave me my -320, so guess what? Now I know that my formula is right. Those parentheses have to be in there for it to work. So when we do this one, it's going to be -5/4 times -4 in parentheses. Make sure that you put the exponent outside of the parentheses, not in the parentheses with it, or you didn't do any good. Okay, I'm going to just come up. Some of you know how to do this. Just come and grab that, because I've already typed it in and just changed my exponent to a 9. Okay, so my answer on this one is going to be 327,680. Okay, hopefully you're feeling pretty good about this. What I want you to do is try one that's a little bit harder. Pause the video now and see how you do. Okay, hopefully you had enough time to do that. Remember, our first step to get the constant ratio is to take the second number and divide it by the first. So if I type that in my calculator, 72 divided by 864, I actually get that it's timesing by 1/12. Now let's think about that. I'm timesing by a fraction. Why am I timesing by a fraction? Well, because the numbers are getting smaller, not bigger. So my constant ratio is 1/12. You can trust your calculator on that. I promise it did a good job. Okay, so to go backwards to the 0th term, what are you going to do? We times by 1/12 to go that way, so we're going to divide by 1/12 to go the other way. So here, let's type that in. 864 divided by, and I'm going to use my fraction again because I like it. It just makes me happy to see it on the calculator screen, but I better type on the right fraction, right? 1/12. Huh, it got bigger. So think about that. Should it get bigger? It should. And the reason why is because if you look at your pattern, doesn't it make sense that the number in front of it would be bigger than the next one?
Sandra, can you either go open up CUD's room or bring my keys back? Thank you.
Okay, sorry about that interruption. Here we go. We're going to type in 10368, and then I'm going to put in my 112. And then the last step, this is always the most important step, to me anyway, and I hope it's an important step to you, is pick a number. I don't want to get a fraction answer, so I'm going to choose, this is 1, 2, 3. I'm going to choose my third term, and I'm going to plug it in my formula and see if my formula is right. So I'm going to do 1/12 to the third power. And remember, if I plug it into the third power, I should be getting 6, and that will tell me if I'm right. So 10368. I guess I didn't need to type it in. I could have used what was already there, but I did. So here's my fraction. I'm going to do 1 and then 12, and then I'm going to raise, oops, there we go. Got to get the right number. I'm going to raise that to the power of 3. And I did get 6, so that means I got it right. Some of your, if you notice, my calculator will put it in parentheses. Some of your calculators will need that to be in parentheses, so you just have to play it by ear. If you test it and you don't get 6, the first thing I would try, because it depends on how you type it in, I would try putting parentheses around that 1/12 and seeing if that fixed it. It's not like the negative one. The negative one, you have to have the parentheses. This one, it depends on what kind of calculator you're using. Okay, so that is it. Hopefully you were able to get an understanding of explicit function, which is the last formula that we are learning in this unit. All right, bye.